Thank you very much, first of all. Today we have the pleasure of having here with me for this brief chat on landslide issues Professor Michel Jaboyedoff from the University of Lausanne in Switzerland, full professor at that university. And let's get into the chat right away. Let's talk about your main topics, the ones that you're currently addressing in your research on landslides at the moment. What are you involved in?
What we are working mostly now is more on rock slope, but mainly now it is related to thermal effect on rock face. It means that the fatigue induced by the thermal heat and cooling, which make change in the stress in the rock face. And we follow always our basic topic was always the LIDAR survey for analyzing structure, for hazard assessment in terms of like susceptibility to rockfall, the volume, and also monitoring. We tried also to monitor the small movement. For instance, we were able to monitor up to 1 millimeter change when we are looking at this thermal change for the rock slope problems. And but it's always also we always work still on LIDAR, terrestrial LIDAR, and rock.
Many different topics, yeah, of course, and all of them interesting. Let me ask you, in terms of practical applications of the research that you are doing, how much you are involved into implementing real solutions for landslide problems?
I think there are two aspects. One aspect is research, like for the thermal. Up to now, exactly, we don't have application on that. I work with also in collaboration with University of Grenoble, with the French, who are working on the passive seismic noise analysis, and they had very good result in a common paper we had on our landslide we are following together, where they discovered that the surface velocity wave decreased 5 days before the collapse. But this is still research, and very promising research, but we are not applying. When we apply, it is more on request of our region, the Canton de Vaud. And for instance, now we are working on risk analysis with WebGIS platform. It means that you can analyze, make the risk. You draw a polygon. You have the houses, then you have some either table dedicated, or you estimate the value of the buildings, vulnerability curves, and so on. And also now we try to do for
what scale?
It is at the scale of our region, which is 3,000 square kilometers around. But this is one aspect, and the other what we are developing is simply now we have a very high resolution LIDAR image that where you have very good reflectivity. You can have up to 80 points per square meter. This is right. And then and since that we start a small project about shallow landslide mapping, because you see the scar, you can do things, and then we will try to characterize what we see. And this is a small project we have. And then you see that there is a difference between applied and what is research, because the research, we hope that, for instance, with the seismic noise, we can do something in the future, having some test site for real monitoring, but up to now it's not the case.
Let's go a little bit in the past of your experiences. You've been studying a lot of case studies. You work with a lot of them. Is there any you'd like to mention for the important lessons learned? Something you can share?
It depends at which level it is. The most recent, it was a shared research also on rock slope, but this was made using ground-based InSAR. This one is, in fact, it's in Norway. this has been we use the Italian one, the Lisalab one there. This is the Norwegian authority who are using this one, but we were able to work on that data. One of our master student worked on that and discovered that the massive is going down and doing like this during the year. It seems that it is related to the water level within the massive and creating, inflating and deflating the massive during the year. And this probably it is one of the first time we can show the process of fatigue of rocks. And this is something I like very much. It's again it's data from another group, but we had a master student working with them for them, and now this master student, she's doing a PhD in Tromsø, also in InSAR.
Of course, cooperation is
Yes.
the key. International cooperation is the key to research efforts in this topic. And I'm wondering, like talking about research initiatives you participated, can you refer our readers or listeners to any research initiative that you deem very relevant for the results obtained, something that people may find, for instance, reports that have been written or landslide risk management,
the recent
implementations,
you
either recent or even the old ones that you think are that you still think are new in a way that it's relevant for landslide risk management practices.
Landslide. I think that always, if you go back to Terzaghi works,
it's the origin of everything.
Yeah. Then there is what as
even your own work in terms of projects that.
It's difficult to say which was the. I think that we improved a lot in many things. I think it's more the tools we get than because everybody worked well and improved the knowledge and things. There are one thing which is really important is now the surface, the topography. We have a high resolution topography, and from that we start to really, this is the large input for natural hazard management and landslide, risk analysis. This hazard analysis. It's really, we started to see a lot of things, but it opens a lot of doors that are not yet used. And also InSAR. And ground-based InSAR up to now is very efficient, and coupled with LIDAR, we start to have really a very nice monitoring. I think most of the advanced are really linked to technology, because conceptually there is a major problem now. I think it's between, if you want, the traditional geomechanics with more Coulomb or another failure mechanism, or even soil mechanics as it is made by British. But there is, the rheology has not really entered in the culture of landslide people. There are only few people working on that, and then we have to merge those two things to make it more relevant.
We know landslide research is an interdisciplinary effort, and it's true that we need to do more on that, but you also somehow anticipated me on the future. What do you see landslide research going? Put in other words, in your opinion, what are the main challenges that are faced by landslide risk managers at the moment? So, like, what are the challenges, and how do you see people overcoming them? Where should we work at?
I think there are different levels. There is the level of the understanding of the processes. As I said, this question of having a well, first having trying to have a larger, a broader view of the deformation processes and how it works, how you pass from viscous to plastic or both. This is one thing. The second thing, I think that as the numerical modeling has improved, but it's still really it's oriented for some aspect. I think that also we must develop a more conceptual modeling, having more conscience of how to develop a conceptual model of landslide, because this is really important to do a relevant monitoring. I mean, this must be improved in a way. And the last thing, if you go toward the monitoring and early warning and then risk management, there has been a lot of land planner who prefer to have a zone where you cannot live or a zone where you can live for a question of responsibility. But at the end, we will live in red zone, and we live, well, not me, but we are forced to live in red zone. And early warning is probably, as many people are saying, is one of the key problem for the future. And it's a problem of well designing them. But the second thing is also to have a good infrastructure to maintain instrument and to follow, having center and then maintain the knowledge. And then all this stuff, we started from the process, which is the hazard, quantifying the hazard and qualifying the hazard, and then to go to the early warning. In between there is the mitigation, but mitigation we know rather well what to do. But
thank you very much. We are almost, I guess, at the end of this brief chat. I'd like to close by asking you, is there any recent article or book or report that you've read and it's worth a recommendation and you want to share it with us?
Recent, I think that there is the book that was written about rockfall by the TRB, the American book, which is summarizing the main thing. It's like the landslide book from Turner, but this is the Turner, and I don't remember the name, but this book is I think, as a general book, is an excellent book.
Reference book.
It's a reference book. Otherwise, in terms of real advanced recent.
Even moving away from books or articles, is there any web resource that you'd like to refer to?
I think in any case, the Dave Petley blog is a good thing to see. We have a lot of information. In any case, there is a lot on the web that we can find now. I will recommend also one thing that is again on the web. It is what we did with Farok, as this is all the report from the SafeLand project, which is there is a lot of information. Maybe not innovation inside, but if you want
a comprehensive reference,
a reference, I will say that this report is up to date, and the rest is really I cannot say directly. There are a lot of new things about articles, but also maybe on the thermal aspect of rocks, the paper from Stock and Collins in Nature Geoscience, which is interesting. It's not new because I found now new former interesting papers about that, about the thermal effect.
Just to close, something about your planned future endeavors or projects, activities, anything you can anticipate to us?
I have to write. I'm at present vice dean of my faculty. Then it's difficult but I will try to write new project. But mainly because it's very narrow what we can do in our research funding agency. We will write something about rockfall susceptibility and monitoring, but also we will try to dedicate on coastal stability, coastal regression by landslide. because this
problem
is
it doesn't affect Switzerland, but of course
no. But we work in Normandy in France, where we have had an article we followed with LIDAR on a boat, and it's interesting because there is a lot now about erosion, but about cliff erosion. In Italy, you have some paper now about stability and so on, but there are some aspects to have a model because there is also the wave effect and so on, and then we'll see. But otherwise, it's to work with, I have PhD student more on modeling. It's to do some how do you say, the discrete element model for rockfall impact and linking with modeling of rockfall. This is the at present.
Thank you very much for this. Thanks.
You're welcome. Thank you.